I'm going to talk about robust payment systems, and more specifically, I'm going to talk about the nonlinear distortionary effects of incentives when you only have some activities that can be measured in the bonus system. And this sounds a bit strange, so let's just dive into an example. Let's say you run a hospital, and you have a deficit, and you're in the board meeting, and you have to cut $100 million. And in this hospital, let's just simplify and say you do two things in this hospital. You do X, and these are the things that are included in the reward system. These are the things you can measure. And in addition to that, you do things that cannot be measured, Y. These are unmeasured activities, the things that are not included in the reward system. It's costly to measure them, or it's impossible. But these are still things you want to be done. For example, X could be the volume of services you provide, and Y is the quality of those services. But it doesn't have to be. It could be X is the number of patients that are that you receive a bonus for, and Y are those patients you do not receive a bonus for. For example, psychiatric patients, but you receive a bonus for somatic patients. And the reward system you're facing is as follows. The total revenue, the income you get, is a fixed sum, you get a fixed transfer, plus a bonus based on X, the number of X you produce. And this is a very common bonus system. Now the question is, if I have to cut $100 million, I have a deficit. Should I cut X or Y, and how much of X and how much of Y? Well, the answer is obvious. Because X is part of the bonus system, you do not want to cut X, you should cut Y. But let's say there are some professional norms, so you can't cut only X. But the more interesting question is, exactly how strong is the incentive to cut in Y compared to X? So let's just work out an example again. You have to cut $100 million, and if I cut in Y, I can just cut the budget by $100 million. I can fire doctors or nurses or whatever, and I cut $100 million, and I'm okay. I have a balanced budget then. If I cut in X and I cut $100 million, I will not be okay. Because if I cut in X, and assuming there is no slack in the organization, if I cut in X, I will also reduce my own income, because my income depends on X. So when I cut in X, I will produce fewer X and my income will go down. So even if I cut my cost by $100 million, my income will go down and I will not have a balanced budget. How much will the income go down? Well, that depends on the size of the bonus. So let's say the bonus is 0.7. For every single X I produce, I get a bonus of 0.7. Now, if I cut $100 million from X and there's no slack in the organization, I will produce 100 million fewer X given a unit cost. Which means that the bonus is 0.7 times 100 million is 70 million. So I lose income equal to $70 million. I only save $30 million by cutting $100 million. So in order to get balanced, I cut even more. I cut $70 million more. Well, I will still lose some income then, so I will not achieve balance, but I'll still have a deficit of $49 million. Then I cut and I cut and I cut. And it turns out that I have to cut $333 million in X before I had a balanced budget. So this example shows me exactly how strong the incentive is to cut in Y compared to X. It's more than three times as expensive to cut in X compared to Y. So obviously this kind of incentive system creates a huge incentive to cut in the unmeasured activities compared to the measured activities. But it all depends on the size of the bonus here. So we can look at it slightly more formally and see how B determines how much you have to cut. So let's do this. Let's say D is the deficit and C is the cut you have to make. Now we already know that if you're gonna cut, or you have a deficit that's D, how much do you save if you cut in X? Well, you only save 1 minus B. When we cut $70 million, we only saved $30 million because we also lost $70 million in income. So it's 1 minus B times the cut you make when you're cutting in X, which means that a cut in X is equal to D divided by 1 minus B. D divided by 1 minus B. Now this is interesting It's a nonlinear thing, so we'll have a look at it. But let's work out a little bit more. The interesting, or the thing we're focusing on now, is how strong is the incentive to cut in X compared to Y. So let's say the ratio between cuts in X compared to Y. Now the cut in Y is just 1 always. It's the same as the deficit. And we're going to have, let's use a unit deficit for an example, 1 divided by 1 minus B. This will be 1 minus B. And let's draw it so we can understand what it is. On this axis we have B, the size of the bonus, and we can make it a share of the total payment, so it could be maximum 1, for example. In that case we have a bonus system. There's no fixed pay, you only have a bonus. Or we could have a capitation system, meaning you have no bonus, there's no A. Everything you get is a fixed transfer. So these are the payment systems you could have. Now if there is no bonus system, you have to cut 1 in Y or 1 in X, so it's the same, the ratio is the same. If the bonus system is such that you 50% of your payment is based on the bonus and the production of X, then it's twice as expensive to cut. This expression here becomes 2. It's twice as expensive to cut in X compared to Y. If the bonus is 0.8, it's 5 times as expensive. And this is the relative expense. If it's 0.9, it's 10 times as expensive to cut in X compared to Y. We're far up here. Now this shows that the relationship is non-linear. We have something like this, meaning that as you increase the reward in the bonus system, the distortions become increasingly large, and they grow very fast. Now you might say, why do I care about this? So what? Well, I think it's interesting for several reasons. So what? First of all, it's interesting or important to be aware of this mechanism, because when you design an incentive system like this, and you're setting the different rewards and determining exactly how much should be a bonus and how much should be a fixed payment, you should know that if you make a mistake, then the mistake will be huge very fast. In other words, these kind of systems are not very robust to mistakes. So it has something to do with robustness. Also, you should be aware of the fact that maybe you try to justify most people know that there is something that is unmeasured, and they say, oh, this fixed transfer will take care of that because you have flexibility to do the unmeasured things when you get A. Well, you do have financial flexibility, but the incentive to do the unmeasured activity is not very strong in these systems because of these non-linearities. There's a huge incentive to do X over time. So just because when you know these mechanisms, you will be aware that different payment systems will have different robustness concerning this problem. So you could have a fixed fee-for-service system, and they will obviously be vulnerable to these kind of problems. You could have a capitation system. A capitation system will not be vulnerable to these kind of problems. So that's they're robust. You could have a pay-for-performance system, in the same sense that fee-for-service will be vulnerable. Pay-for-performance will also be vulnerable to this, but there's a slight twist here. You have to look at the ratio, or how many unmeasured activities you have compared to the measured activities. So it all depends on how important they are and what you can measure. For example, it may be easier to measure activities than outcomes, but it all depends on the ratio and importance of the unmeasured to the measured activities and how much you care about them. So this is one mechanism that I think is quite important when you try to design a payment system in health and in other areas as well. You have to be aware that Small changes can actually lead to big distortions in the outcome because of this non-linear mechanism.